Professor Xavier Vives is Professor of Economics and Finance at the IESE Business School. He's going to talk about a more structural issue of the market, or perhaps a different structural issue in the market. How can we deal with herding and other behavioral issues?
As big as it gets. Okay, so thank you. So let me start by thanking the Newton Institute for inviting me to be here. So now we change gears. So this is more theoretically oriented talk. And I will speak about the topic that I have been assigned on herding. And basically I will connect it with the information aggregation properties in the market, and also to the rational expectations models that Professor Pesseran has dealt with before. In fact, some of this material is from a recent book of mine in which I deal with informational learning in markets. So let me start with some examples of behavior that some people have taken as a model for financial markets. So this is, let me see if this is the, this is a painting by Peter Bruegel the Elder, called, I think, the parable of the blind. In fact, there are some blind people leading other blind people. The first one falls into the ditch, and then others follow. Okay. The second parable are this string of penguins on the verge of a cliff, and as you know, so they are all standing there to see which is the one that goes first. It may eat more fish, but at the same time may be eaten by a killer whale. Okay, so is there anything in common on those two situations? Do really people behave as a herd of penguins, no? They follow a first individual that jumps off the cliff. We definitely learn from other people, and we think to ourselves whether we should buy a book because other people, it's a bestseller, other people have bought a book. Must be good, right? Should we go into an empty restaurant when visiting a city? Well, now I was in London and it was difficult because all the restaurants were quite empty because of the crisis. But in general, you can follow this advice. And more to the point of the talk, can we trust markets to provide the right signals for decision making? Herding is the situation in which individuals infer information from the actions of others, and here, well, again, it's a little bit the list of consumers buying best-selling brands, tourists patronizing popular restaurants, academics choosing to research hot topics. Okay, so I mean, anyone trying to do a thesis or having done a thesis, has thought very hard what's going to be hot. Right? Investors, now again, more to the point, buying a stock when others buy the stock, or depositors running on Northern Rock when others do. Okay. In terms of modeling, there have been quite a few advances relatively recently in social learning and economics and sociology on this type of issues. And the basic idea, or one idea, is the following, that if actions of others suggest strongly a certain action, then a rational individual, completely rational, Bayesian, whatever you want, may ignore his own information and follow the crowd. To say, have a certain conformity of actions with the others. When this happens, information is lost and is not revealed to others. Okay, so we say that an informational cascade happens. So basically, this situation happens when making a decision, you make your decision independently of the information you've got. Okay, and just follow the public information received. Learning stops. Okay, and then this type of cascade implies a herd in the sense of conforming actions. And the point is that the outcome may be very, very inefficient. Okay, so the early literature here, there was many examples. So the restaurant example, again, is one of the typical ones. If you have not seen it, let me go through it very quickly. So you have, these guys are Bayesian patrons, obviously, that they have a prior of the restaurant A and B. The prior favors slightly A over B. There are 100 customers. They arrive in sequence, and each one has a private noisy assessment, a signal of the same precision of the quality of the restaurant. Signal may give a good news about A or about B. Okay, so you have a good signal about A, you go to A. Good signal about B, you go to B. Now suppose 99 have good news about B and 1 about A. Okay, so this means that collective wisdom, putting together all the information of everyone, everyone should go to B, right? Which is the one which information aggregation would tell. But well, A arrives first. Okay, she goes first to the restaurant. And since it's got A as a signal, goes to A. Then the second infers that the first patron got A as a signal. This cancels the signal that the second person receives B. They are of the same quality. And then you go with the prior, which is slightly in favor of A. Okay, and then that's it. Okay, then the second in line chooses A irrespective of his signal, and therefore his choice does not convey any information to the third person in line, who ends up in the same position than the second, and then for all the others, and so on. Everyone chooses A, even though B is better, with very high probability when aggregating all the information. Okay, so that's an example of herding and a very inefficient outcome out of rational learning. Okay, and everyone is rational, Bayesian, but then the outcome is very inefficient. Okay, so we may say irrational. I don't like to say irrational. It's just very inefficient from the social point of view, but it's based on rational. Now, this leads us to two views on the market. There is the view of informational efficiency, in which the stock prices reflect the available information, and prices in the market reflect the available information in the hands of traders and fundamental values. And then there is the other view, the dark side, if you want. Okay? So the dark side, prices are in the hands of short-term speculators, insiders, manipulators, and subjects to fads, herding behavior, bubbles. Okay? Before the crisis, I think many people believed this. Now, after the crisis, probably more people believe the second. Okay, so but I think we have to be careful. We have to be careful and do not follow fads in the analysis. Okay, this debate, in fact, goes back already to the debate between Lange and Hayek on the viability of socialism. So probably you may not be attuned to this debate, maybe some of you. So the debate was about essentially Oscar Lange saying, well, socialism is viable because a competitive allocation can be replicated by a central planner. Hayek said, no, this is not possible because the marvel of the market is precisely that it aggregates the information of all the different pieces of information, okay? And this cannot be replicated by a central planner. Well, in the end, it seemed that Hayek was right on this because the Soviet Union did particularly well, right? Okay, so let me just skip the quotations. There are several slides I will skip. Then, on this informational efficiency of the market by Hayek, rational expectations are built on top. I will not go into that because it has been already explained by Professor Pesseran, but you can go back to Marshall. So already rational expectations are in Marshall, as many other things. So this is a very simple example how a cloth manufacturer forms expectation of future wages, taking into account the immigration flow. That's basically taking into account a model of the economy, okay, which was the influx of immigration would depress wages, so therefore you take this into account. Very simple idea. In fact, rational expectations is a relatively very, very simple idea. Okay. Now we go to the other side. Typically, we put Keynes, on the other side with the famous quotation of the beauty contest. Basically, these people chasing the average, or the market or trader chasing the average opinion of others, okay, instead of looking at the fundamentals. Okay. And so let me skip the quotations, and now we come to modern times. Okay, so more modern times, and so modern times now here are defined by the Turner Review on the financial markets, I guess. And also there it is posed the question that the crisis also raises important questions about the intellectual assumptions on which previous regulatory approaches have largely been built. At the core of these assumptions has been the theory of efficient and rational markets. They use rational markets, I think, in a very imprecise way. So I don't know what it means, a rational market. I know what means a rational individual or irrational. And then they say efficient markets can be rational. Well, and they continue, and then they have, well, several, if you have read it, several observations. Now, so the central issue is, again, can we trust markets to provide the right signals for decision making? Can we trust the stock market? Can we trust the futures market for oil, for example? Or when they were going crazy, really they had gone crazy, the futures market, or no? Or that there were a lot of supply constraints and extreme demand projections. Okay. So are the two views compatible, these two views on markets? Are crises and bubbles in markets consistent with rational behavior by investors, or we really need irrational traders with behavioral biases making systematic mistakes one after the other to explain all the things which are happening? Okay, so let me cite already on the first side, let's say, on the side of thinking that we can explain crisis, bubbles, and in fact the crisis basically with rational behavior and incentives provided to traders. For this would be an outline of a long talk, so I will just touch on a few issues here. First of all, we should discuss, we will not have much time, but we should discuss whether people are rational, are act in a Bayesian way, they process information efficiently or not. There is a lot of debate, theoretical, with behavioral economics, with experiments. My reading of it is that Bayesian behavior by traders and agents continues to be a central assumption, a central working assumption. Okay, and maybe yes, discrepancies here and there, but this continues to be the central Bayesian assumption. And I will not justify it more. Okay, so and let me maybe move on because I would like to. We can discuss it. We can discuss it later. Okay, maybe in the debate. Okay, so now let me contend that what we have seen before on rational expectations models, what I've told you on this view of the informational efficiency of the market, and what I have told you of this extreme inefficiency of herding, this sequence of rational agents making a wrong decision, okay, and with a very inefficient social outcome. In fact, all this is explained by the same principles, okay, by the same principles. And one very basic principle which is behind all these inefficiencies, potential inefficiencies, is basic information externality. Okay, and the basic information externality is the following: a trader or agent, when acting, does not take into account that the informational benefits of his actions on the other traders. So you do not take into account that when you react to your information, apart from your private benefit, whatever it is, this will end up being impounded in prices, in quantities, etc., in market observables, that other people will look at it and may benefit from it. So you do not take into account. Okay? And this is a fundamental information externality that drives most of these inefficiencies. Okay? And then what happens is that, in fact, in situations in which the trader or an agent cannot fine-tune his action to his information, like in this restaurant example, which is 0-1 decision, very coarse decisions, then there is no way for your information to get impounded into the public statistics because it's too coarse. But when you have much more a finer grid of actions, like many times in financial markets, then this is different, okay? And much more of your information can get impounded into public statistics and prices. Okay. Let me just show you an example of how this happens and how this information externality when you learn from others works in a very, very simple model. Suppose we have agents arriving in sequence, and each agent in one period, and this is a very simple model, just a prediction problem. So each agent tries to predict a random variable theta, okay, and tries to minimize the mean square error of this. It's very, very simple. So for the moment, it's extremely stylized. And what information has the agent available? A signal, a private signal, which would be the true value plus noise, let's say white noise, and plus a noisy version of the predictions of each predecessor. So this is the prediction of predecessor K. You add some noise, and that's what this guy sees. Okay, so it's a very simple problem. You have, and this is like the process of market aggregation of information, and this is the private signal. And let's say all random variables are jointly normally distributed for simplicity. let me skip the example. Then just form the conditional expectation of theta on all the vector of public signals, okay? Call this theta sub t. This, given in our structure, is sufficient statistic for public information, follows a martingale, as to say that the prediction of today given yesterday is yesterday. And then we can look at what would be an individual prediction of a trader, of an agent. And it would be just the conditional expectation given private and public information. Given this normality structure, this is a weighted average of a private and a public signal. And the weights, what are the weights? They act to 1, and they are according to the precisions in the signal. So this is the private precision, and this is the public precision. Okay, the precision incorporated in a public statistic, and the different weights are according to the different precision. But look at what happens here. So here we have a kind of self-correcting property of learning from others. So if you inherit a lot of public information, tau t is very large, then the alpha t will be small. But if the alpha t is small, then the next tau t will grow more slowly. Why? Because, well, your reaction, what makes the public statistic informative is your reaction to private information, your reaction to your private information. Okay, so this tau t is increasing, this minus 1 to the alpha t squared. Okay, this means that learning will be slow. When there is a little bit of noise, learning will be slow. But however, you will end up learning, so this, in a sense, this theta t will converge to the true theta, and this, the reason is why if you inherit very little public information, then in fact the alpha t will be quite large, and the increase tau t minus 1 will be quite large. Okay, so, and this speeds up learning. Okay, so it's between those two boundaries, and then in fact, let me show it to you graphically what happens. So if you look at here at the accumulated public precision, and in here at the periods t, forget about those two branches, public precision is accumulated in this kind of concave way. In fact, according to the t to the 1/3 power, instead of the linear way, which is the typical estimators would grow linearly. So this is kind of slow accumulation of information. Okay. Is this optimal? Well, no, this is not optimal. Why? Because there is this information externality. When I react to my information today, I do not take into account that if I would react more, I would benefit the guys that continue, okay, and I would reduce their mistakes. But this I do not take into account. If I were to take this into account, and I internalize this, okay, if I were to internalize the welfare of the other investors, if you want, the guys that follow in line, then, and we were to discount their welfare with a discount factor, let's say delta, then in fact we would be accumulating public precision or information, if you want, at a higher level, either depending on the discount rate. Okay, and so the distance between this, which would be the market solution, and the other branches is what characterizes the information externality and the inefficiency. Okay, this is a very smooth model, and you learn, but you learn slowly. In the herding restaurant example, it's similar, but it's so stark that you end up not learning, and in a very, very inefficient outcome. But the difference is just because of the assumptions you've made on what you can do, on the strategy set. Okay, so that's quite important. And markets are closer to this model than to the very coarse 0-1. Okay, when we trade and when we model trading in markets. Okay, now I've just talked about information externality, but obviously in a market you have not only information externalities, but also payoff externalities. What I do affects the others through their profits or utilities. And then this implies, let me skip this bit here, this implies in a dynamic world that these learning dynamics may be modified. And let me just explain briefly how this would go, and if I have time, how can you explain some supposedly market anomalies. Okay, so let me, okay. So in here, if on top of this very basic model, we add, for example, and realistically, market makers, in which they quote a bid-ask spread, and the bid-ask spread depends basically on the information asymmetry they face. So suppose the market makers face informed traders and uninformed traders, and they have to protect themselves with a higher bid-ask spread if they face more informed traders, so typical, what we call in economics an adverse selection problem. If this happens, then what happens as more public information is accumulated, as more information is made public? Well, that this adverse selection problem is lessened. And market makers react to this by decreasing the bid-ask spread, okay, making the market more efficient, in this sense, in this precise sense, decreasing the bid-ask spread. And then what does this imply? Well, this implies that risk-averse investors, informed investors, since they see a smaller spread, they are enticed to trade more aggressively. And they rely more on their private information, and therefore more of the private information ends up being impounded into the public statistic and the price, speeding up the informativeness of prices. Okay, so this is a case in which the payoff externality induced through market makers speeds up learning. And if you want, in more financial terms, makes price discovery effective. Okay, so that's a very important function of, for example, of market makers. Okay, market anomalies. There are many market anomalies which have been highlighted by empirical work. Well, the value of technical analysis, and somehow for some people it's a market anomaly. So now, in fact, I've read recently that, again, the patterns of head and shoulders is so evident now that we should be out of the crisis soon. Okay, so I don't know if to believe that or not, obviously. That we can discuss later in the debate if you want. But why, I mean, in an efficient market, how could this matter? How these head and shoulders patterns could matter in a market in which prices give you the information, no, that you need? Well, in fact, let me then just comment very briefly on some of those. In fact, there is no mystery here from the point of view of analysis and, in fact, of rational expectations model. So technical analysis matters as long as you don't have a perfectly efficient, risk-neutral market-making sector. Okay, so except in this case, in which then the current price is a sufficient statistic for everything you need, basically, for all public information, except in this case, when market making is subject to risk aversion, basically, which is more normal case, then you need to look at the sequence of past prices. Okay, so the current price is not a sufficient statistic. Okay, so how can we explain patterns of excess volatility and prices departing from fundamentals? How can we explain instances in which we seem to see that prices are much farther away from fundamentals or perceived fundamentals than the average opinion of investors in the market? How can we explain situations in which traders seem to give too much weight to public information, as in Keynes's ideas? Well, all this can be done in a relatively standard rational expectations model with rich enough rational expectations models. For example, excess volatility patterns are very normal when market makers are risk averse. Again, when we do away with this fiction of a perfectly efficient risk-neutral market-making sector. Excess volatility is aggravated, for example, when there is more asymmetric information. Okay, and guess what? What are the instances of the largest bubbles that we have seen in the history of the recent history? And by recent, I mean from the 19th century, let's say, not from Roman times, or maybe probably is also true, but let's say from the 19th century. Well, new products, railroads. So railroads come in, big bubble. Okay, during the boom of the car industry, probably the 20s, another big bubble. The IT revolution, another big bubble. Now, the present crisis, probably the new product. The new product are securitized subprime mortgages and complex derivatives. Okay, so whenever a new technology, a new product is introduced, asymmetric information increases a lot, because there is a lot of asymmetric information, so that different beliefs about how this thing will go. Okay, different beliefs of how this thing will go. And whenever this happens, the very basic rational expectations model, enriched with private information, okay, with risk-averse market making, etc., give you the prediction that you'll have more macro instability and excess volatility with respect to the typical measures. Okay, so again, so there is no mystery here, and it's compatible with our models. Okay, let me maybe skip this because I should be finishing, and let me just tell you a couple of things on policy implications, and then we'll leave other topics for the debate. What policy implications can we draw with this type of modeling and approach? Well, quite a few. So, for example, one is that more transparency, in fact, may reduce welfare, okay, instead of increasing it. Why? Well, because sometimes one has to be careful. More transparency and provision of more public information may make people precisely coordinate on wrong expectations. Okay, and cause more instability. Okay, so this in runs, in panics, this has been, in fact, also empirically seen, but also theoretically it's robust. That's one example. Another example: how can we correct for this fundamental information externality that we see in markets when asymmetric information is an important problem? How can we? Well, in the usual way. Okay, what's the usual way for economists? Okay, so that's not for everyone probably, but the usual way for economists is to use tax subsidy schemes. Okay, what are tax subsidies? Well, tax subsidy schemes that can be put on realized fundamentals or aggregate activity. Okay, and then once you can provide this type of tax subsidy schemes on ex post realized fundamentals and aggregate activity, then you kind of disentangle a little bit the effects and make traders internalize those externalities. Okay, so how, for example, then you can design those instruments to dampen the impact of noise without also dampening the impact on fundamentals, induce agents to internalize this information externality, improve the speed of learning, restore efficiency in the decentralized use of information, or guarantee that welfare increases with any additional public information. Because otherwise, so in this context, once you correct for that, then more transparency is always good. Okay, but once you have corrected for the basic information externality, otherwise, more public information may be damaging, as I said before. Okay, so more we can discuss later. Okay, so let me skip this and conclude with the following. So one of the messages I wanted to convey is the following, is that apparently contending theories which look very distant, like this rational expectations, informational efficiency view of markets, and the herding view, okay, in fact, built on the same, or can be explained with the same principles of Bayesian decision making, okay, so that you can understand them, rather a framework to understand them, and that therefore we do not need irrational agents or purely behavioral agents to explain all kinds of anomalies of herding behavior, crisis, and crashes. Okay. Policy conclusion that I leave here just maybe for the roundtable, but I mean, you can take up. So the implications of thinking that how the world works is through the impulse of people who are centered on rational objectives, or centered on behavioral just rules, okay, which may make systematic mistakes in relation to the rational objectives they may have, and procedures, lead to very different policy conclusions. So the first one would lead to this type of tax subsidy schemes that economists propose, leads to certain types of disclosure policies, and not others, perhaps, and leads also to the regulation of conflict of interest, although I have not talked about this here, but which is central, because it's driven by incentives. If you think that people make mistakes, basically, and that they do not know what they are doing, okay, I mean, I'm very rough on this, but let's see, then what you need, obviously, is paternalistic intervention, very intrusive regulation, and restrictions on behavior, okay? And so, and we'll see, and now the debate, I think, is still on where are we going? So whether we will go more towards the first type of measures or towards the second, and I'm not sure where we will land. Thank you.
Well, Professor Vives.
Could I just ask, you speak here about introducing a tax or subsidy on realised fundamentals. Can you give me an example of what that is?
Okay.
Could you just
Yes. No. Yes. The question is to put to add some more detail on how to understand tax subsidy schemes in this respect. So so basically, this would be could be that due to the information externality, for example, you have just one example. You have too little incentive to collect information, private information, because you rely too much on the public statistic that comes. Okay. Well, then in this case, a subsidy to private information collection could work if well designed. Okay. And then there will be much more sophisticated things, but this is a kind of a straightforward. Okay. Yes.
It seems to me the parables elevate the debate to a higher level of confusion, which may be all the progress we can expect. But for example, in the restaurant example, one of the last reasons to eat in an expensive restaurant is the quality of the food. What's the point of eating somewhere where there's no one to see or no one's heard of the name? And in the case of financial agents, who seem to know next to nothing, you're more likely to keep your job if you're wrong in a consensus than if you're wrong in a minority.
Yes. Yes. But is this a question or a statement? I understand. So the
where is the progress at a higher level of confusion?
I
mean, the definition of herding being rational is totally circular, because it means that whatever makes people herd is rational.
No.
The question is the definition of herding circular?
Okay. No. Of rational herding. No, I don't think so. I mean, if we understand rationality of people having some objectives and trying to pursue them, in the best way they can, okay, and processing information the best way they can, and trying to make us, an effort towards the objective. So in this sense, it's not circular, because these guys are trying to, they don't follow an exogenous rule that someone has given them, they try to optimize in this respect. But this, I think, by the way, can explain, for example, what you said of the, in fact, this also goes back to Keynes, that it's basically better to fail conventionally, than to succeed unconventionally. Okay, but this is very much, I think, it's a rational response to an incentive structure in place. Okay, so but I think it's a rational response. So there is nothing; it's not inconsistent at all with what I said. If we were to change the incentive structure, then the rational response would change. Okay, and maybe people would be more imaginative, right?
Okay. I think we'd better stop there so we can
Okay.
move on. Thank Professor Vives. Thank you very much indeed.